Welcome to this video, which is a quick response to a WhatsApp question. You can always join our WhatsApp groups and engage with others. Okay, let's look at rate equations and how you can determine the order of a particular reagent in a rate equation. So there's a general rule that you can follow. What happens is that when we double the concentration of a particular reagent, we check what happens to the rate. So when we double it, we check what happens to the rate. We can triple it in other cases. So there's a general rule here. If you double the concentration of a particular reagent and you realize that nothing happens to the rate, there's no change in rate, then you know it's zero order with respect to that particular reagent. And then if you double the concentration of a reagent and then your rate is also doubled, then you know that it's order number 1 with respect to that particular reagent. If you doubled a reagent and the rate is quadrupled, you know that it's order number 2, second order with respect to that particular reagent. And for you to be able to do this, you need to hold one of the reagents constant. So let's go through this again. When you double the concentration of a reagent and nothing happens to the rate, you know it's zero order. When you double the concentration and the rate is multiplied by 2, it doubles as well, it's order number 1. When you double the concentration and your rate quadruples, you know it's order number 2. So let's apply this to a specific example. Nitrogen oxide plus oxygen, here you get nitrogen dioxide. So you're given 3 trials, and in most of the cases you're going to be given at least 3 trials. So let's see what would happen here. You see that for trials 1 and 2, oxygen is constant, so we can analyze for nitrogen oxide because our oxygen is constant. So what has happened to the concentration of nitrogen oxide in this case? It has moved from 0.1 to 0.2, which is doubling. So it has been doubled. There, when it comes to the rate, it has moved from 0.04 to 0.16, and you can check this by simply dividing your 0.16 by 0.04. You realize that it is quadrupled. So we have doubled the concentration and our rate is quadrupled. That means that it's second order with respect to nitrogen oxide. So the order is number 2 with respect to nitrogen oxide. Let's see for oxygen. We have trials 1 and 3 for which nitrogen oxide is constant. So let's see what has happened to the concentration of oxygen. It has changed from 0.25 to 0.5. So that would be double times 2. And when we check our rate, it has moved from 0.4 to 0.8. It has also doubled. So that means that it's order number 1 with respect to oxygen. So if you were to write the expression, the rate equation, it would be equal to K, concentration of nitrogen oxide raised to the power of 2, and concentration of oxygen raised to the power of 1, which is the order of oxygen and the order of nitrogen oxide respectively. Okay, if you were to find K, you would simply take any values from any of the 3 trials and substitute to make K the subject of the formula, and take K when it comes to units. The units of K are very important here. So you simply substitute the values from any of the trials and make K the subject of the formula, paying particular attention to units. So in this case, K is equal to 1.6 mole squared per second. Okay, let's look at a case where you can't hold one of the reagents constant, and where we don't double but we rather triple the concentrations. So if you check here, for trials 1 and 2 here, our B is constant, but our A, the concentration has tripled. And when we check our rate, it has been raised here. It would be 3 to the power of 2. So that means that our order is 2 with respect to A. Okay, so this is the power to which we have raised our 3 in order to get our rate, which is times 9. So it's second order. When it comes to B, if we wanted to analyze the effect of B, the order of B, then we have to hold A constant. But when you check, A is not constant for all the 3 trials. So we can only go by trials 2 and 3, the way A is doubled. Let's see what has happened to B. B has also doubled. And when it comes to our rate, it has been multiplied by 8. So we have to create an equation and solve for the order of B. So how do we do that? We have to write our expression, our rate expression, the rate equation. K concentration of A raised to the power of 2. Why? Because we now know the order of A, which is 2, and B raised to the power of X, which is our unknown order. So now we substitute the changes that have taken place there. We know that our rate has been changed, has been multiplied by 8. We know that our concentration of A has been doubled, so times 2, and then to the power of 2, which is the order of A. And then we also know that our concentration of B is doubled, so times 2 to the power of X. So when you solve that new expression, you realize that your X, the order of B, is equal to 1. So I hope this will help you to tackle questions that involve reaction rates and order. See you in another video.